Hello, Adam Zavacky here with my attempt to remake the exercise number 4 from our last exam. This is my second attempt where I set up a new setup and I will use a black pen so it could be more visible, I think. Okay, so let's start with part G of an exercise because it's the best part for me to use later on. So exercise G. Let's consider a function f, which is y is equal to x plus 4 divided by x plus 1. I will get this 2 in front of a bracket, so it will be like 2 x plus 2 x plus 1. And I will better get this 2 in front of the whole fraction, so it'd be like 2 x plus 2 x plus 1. Then I will add a nice 0 to the numerator, so it will be helpful for me to divide this into two fractions, but I will write this with the nice 0 right here. X plus 1. Okay, with this nice 0, as I said, I will divide this into two fractions, so it's like 2 x plus 1 x plus 1, where we can see where that the first part is just nicely written 1. So I will write it then like 2 1 plus 1 over x plus 1, and I will multiply this whole thing with 2, so it's equal to 2 plus 2 over x plus 1, and I will get it to final form as in the exercise, so it will be like 2 plus 2 divided by x minus 1. I will move on to the part B and C of the exercise, where I need to find the what is the equation of its vertical and horizontal asymptote, and I will get this in summary as the part B and C, where I can see easily that horizontal asymptote is actually m from the graph, so it's minus 1. Also, I will write it like x is equal to minus 1. It will be easier for me to then get into graph with this, and for the horizontal asymptote, it's the n from the graph, and it's 2, and I will also write it for myself as this. Okay, I can now easily draw a graph. So it's the part I, and I will write the horizontal and vertical asymptote in the graph, where the horizontal asymptote is on number 2, so it's right here. So okay, and the vertical asymptote is minus 1, so it's right here. Okay, and now I will get to the graph. Now I will draw a graph. I will first write myself the equation in this form, so it's like y is equal to 2 plus 2 over x plus 1, and I will write it like I will choose that I will need to get to the x random value from the graph so I can see how it behaves then. So at the first, let's say I will write if x is equal to 1, then it's like y is equal to 2 plus 2 divided by 1 plus 1, and it's whole like 2 plus 2 over 2, which is 2 plus 1, which is 3. So if x is number 1, the y value is number 3. So we will write it right here. And let's say if x is equal to 0, then y 2 plus 2 divided by 0 plus 1, which is 2 plus 2 over 1, which is 4. So I can see that if x is 1, then y is number 4. So the graph goes something like this. And I will also add for the value of x some negative numbers to see how it behaves on the left side of the graph. So let's say that if x is equal to -2, then y is equal to 2 plus 2 over -2 plus 1, which is equal to 2 plus 2 over minus 1. So it's it's 0. So if x is -2, then its value is 0. And if x is equal to -3, then y is equal to 2 over -3 plus 1 plus 2. That is -3 plus 1. It's 2 divided by -2, which is -1 plus 2, and it's equal to 1. So if x is -3, then the y value is 1. I will write it myself like this. And from this, we can see that this graph goes something like this. Yes. Okay. And then I will move on to find the domain, and it's a part D and part A, where I will find the domain and range. So at first, let me find the domain of a function. And from the graph, we can see that the domain of this function is every single value of x. Yes, every single value of x except x cannot be except -1. X cannot be equal to -1, because as we can see from the graph, the graph is coming close to -1, but it will never reaches it. It's really it's similar with the range of the function, where the range of the function is all possible variables of y except 2, because as we can see from the graph, the y is coming really close to 2, but it never reaches it. So it's all variables of y except 2, so y can be equal to 2. From this, I will move on to exercise F and E, where I will find the intercepts of this graph, horizontal and vertical. Oh no! Sorry, I messed up. In F and E, I will find the y and x intercept. So I can easily see from the graph that x-intercept is -2, so is equal to -2, but I will make sure this by adding a value of 0 to y, so it's like 0 is equal to 2 plus 2 over x plus 1, where I will get -2, so it's like -2 is equal to 2 over x plus 1 times x plus 1 minus 2 times x plus 1 is equal to 2, where it's like -2x minus 2 is equal to 2. I will get there plus 2 to the whole thing, so it's like -2x is equal to 4, and I will divide the whole thing by -2, and then it will be x is equal to -2, as we can see. As I said, we can see it from the graph, but we made sure that this is right. I will find the next step, y-intercept. It's almost the same process. At first, I will look at the graph and see what is the y-intercept. Okay, as I can see, the y-intercept on the graph is number 4, but I will make sure that that it's really like this by adding the value of 0 to the whole function, so then I can see what it really is if I wasn't mistaking myself. So it's like y equals, let me see it again, y is equal to 2 over 0 plus 1 plus 2, and this is 2 over 1 plus 2, and it's all equal to 4. I was actually right, and that y-intercept is 4. The next, I will move on to the last part of the exercise, and that's part H, where I describe the asymptotic behavior of the function f with regard to its vertical and horizontal asymptotes. So I will start with the vertical asymptote, which is h, which is vertical asymptote, which is -1. So we can see from the graph that as x approaches -1 from the negative sides, y is going to infinity, but the negative infinity. It's easily to be seen right here. So as x from the left side is approaching -1, then the y is approaching the negative infinity, and as the x is approaching -1 from the right side, the y is approaching positive infinity. So as the x, the right side approaches -1, also from the right side, y is approaching positive infinity, and this is the vertical. This is like the explanation of the vertical asymptote, and now I will move on to the horizontal asymptote, which is really similar. And as we have already said, the horizontal asymptote of this is 2, and as y is approaching, we can see it here, as the y is approaching 2 from the positive sides, no, from the top, like we can see it here, the x is approaching positive infinity. So as y from the top is approaching 2, then the x is approaching positive infinity. And as y, it will be same, but with the negative signs, because we can see as the y is approaching -2, no, not -2, as y is approaching 2 right here, the x is approaching -infinity. So I will write it like as the y from the bottom is approaching 2 on the bottom, the x is approaching -infinity. This should be all. Hopefully I did not forget anything, and hopefully it's more visible now. Thanks for watching. Have a nice day. Bye.